In this video here, we're going to take a look at tangents to polar curves. Now, if we are given a curve of this form here then, so r is equal to f of theta, then we can write this as a parametric curve in Cartesian form using theta as our parameter. And doing so here then, we obtain the following. So x here is equal to r cos theta. Now if r is equal to f of theta, then we get f of theta cos theta. And then doing the same here for y, so y is equal to r sine theta. So in that case, then we get f of theta sine theta. And now by differentiating parametrically here, we can find the gradient of the curve at any point. So just recall then for parametric differentiation here, dy by dx is equal to dy by d theta divided by dx by d theta here. Okay. So let's take a look then at how we can use this information to find tangents to polar curves. And as you might have guessed here by the title of this video, we want to be able to find tangents to a polar curve that are either parallel or perpendicular. So to find a tangent that is parallel to the initial line, we set dy by d theta equal to 0. And then to find a tangent that is perpendicular to the initial line, we set dx by d theta equal to 0. So please do make a note of these here. These are really important then for exam style questions that are involving tangents to polar curves. And we'll see this in action very shortly here as we work through an example then for tangents to polar curves. So there we have it. That gives us everything that we need here then for our introduction. Let's just take a look then at one example. So let's take a look then at this one example here for tangents to polar curves. So for this question here, it asks us to find the point on the curve here of r equals e to the 4 theta, for theta between 0 and pi, where the tangent is perpendicular to the initial line. And as we can see here then, it says give your answer to 3 significant figures. So to get us started then, let's just note this equation here. So r is equal to e to the 4 theta. Okay, like so. And if we're looking for where the tangent is perpendicular to the initial line here, and what we need, so we need here, we need dx by d theta, and we need this to be equal to 0 here. Okay, so we need dx by d theta is equal to 0. So don't forget then, when we're working with polar coordinates here, x is equal to r cos theta. Okay, so x is equal to r cos theta. So in our case then, for r equals e to the 4 theta, what we have then for x here is x equal to e to the 4 theta cos theta. Okay, so obviously then to find dx by d theta here, that's the derivative of x here with respect to theta, then we clearly need to use the product rule here. Okay, so in that case then, if I let u equal e to the 4 theta, and if I let v equal then cos theta here, like so, and we also need u prime here, so that's the derivative of u with respect to theta, and we also need v prime here. Okay, so nice and straightforward here then, the derivative of u with respect to theta here, we get 4e to the 4th theta, like so. And then for v prime here, again, nice and straightforward, just differentiate v with respect to theta, we get minus sine theta there. Okay, so now just using the product rule here then, what we find for dx by d theta here, so for dx by d theta here, what do we get then? Well, I get 4e to the 4 theta times cos theta, so 4e to the 4 theta cos theta, and then we subtract here then e to the 4 theta sine theta. Okay, because we're just timesing u and v prime together here. We then have minus e to the 4 theta minus e to the 4 theta sine theta. Okay, and what I can do now then is factor out the e to the 4 theta here. So we can factor out e to the 4 theta then, as we just mentioned. And in that case, then what do we get here? Well, as we can see, then we get 4 cos theta. So 4 cos theta. And then we have minus sine theta here. Okay. And as we mentioned, then we need dx by d theta to be equal to 0. So we set this equal to 0 here. Okay, like so. Now in that case then, what we've got here is e to the 4 theta equals 0, and we have 4 cos theta minus sine theta equals 0. So for the first one then, e to the 4 theta is equal to 0 here. And the issue here then is there are no solutions for theta, right? Okay, so we have no solutions for this equation. So no solutions for theta. Okay, so no solutions for theta there. However, for this equation here then, so we had 4 cos theta minus sine theta, and this is equal to 0. And what I can do here is add sine theta to both sides. So we get sine theta is equal to 4 cos theta. And then if we divide both sides here by cos theta, we get tan theta is equal to 4 here. Okay. And in that case then, theta here, so theta is equal to tan inverse of 4, right? So tan inverse of 4 there. And in that case then what we get here is 1.326 here. Okay, don't forget we work in radians here, as we can see for the domain of theta here. Okay, so we're nearly done now. All we need here then is the respective value of r then for this value of theta here. So in that case then, we know r is equal to e to the 4 theta. So if theta is equal to 1.326 then in that case, r is equal to e the power then of 4 times by 1.326 here. 1.326 here. Just put this into your calculator here. As you would imagine, this will be quite a large number. So what I get then is 201. I get 201.1397, so on and so on here. Okay. So we're looking for the point here. So let's just give this then as a coordinate. So don't forget then for polar coordinates here, our point is r theta here. So what we say then is the point, so the point on the curve, here, where the tangent is perpendicular. Let me just write this down here in full. The tangent is perpendicular to the initial line here. So our point then is, as we said, we get r theta here. So in that case then, r is equal to, well, to 3 significant figures here, we get 201. We get 201 there for r. And then for theta here, well, to 3 significant figures here, that would be 1.33 there. Okay, 1.33. And there we have it. So that gives us our solution there. This is the point on the curve where, where the tangent, I said where the two tangents are. It's just a single tangent here. So where the tangent is perpendicular to the initial line, that is given then as 201 and 1.33 there. Okay. So there we have it. So that gives us the solution there to this question. And that brings us to the end then of this video here on tangents to polar curves.